Basically, I made a thermionic diode. So it's like the old vacuum tubes that they used to use in computers. It's the same principle, but without the glass around it. What we have here, this is a vacuum chamber. So this allows me to pull high vacuum on the system. And this is done through a rough pump back here. And then behind is a turbo pump. And that allows me to get down to 10 to the negative 7 torr when atmosphere is 760 torr. And inside there is a filament that got from a hydrogen bulb. You break the glass envelope and then I would put it in a support structure so that the filament's exposed, and then that's the cathode, and it produces electrons thermionically and releases a cloud of them. And then beside it there's a stainless steel plate that is connected to a alternating current source, and whenever and this alternating current source, the power comes from the wall, but it goes through an isolation transformer, and then it's run through a variac to lower the voltage. And when on the alternating current, when it's positive, the electrons will flow from the filament, from the cathode to the plate, allowing current to flow through the circuit. And whenever it goes negative, the electrons can't flow into the plate, and so no current flows. So what you can see here is you can see the alternating current right here, and it's rectifying it, so what you're getting is only direct current flowing through the circuit. And that's the main point of this diode, is to convert a alternating current to direct current. This is an ion pressure gauge, and it allows me to tell with low pressure. So it's right now reading about 6 times 10 to the negative 7 torr. These two are power sources. The bottom one controls the voltage and current to the filament, so this allows me to adjust how many electrons the filament is producing. This one I'm currently not using right now, but I use this to get my IV characteristics of the diode, so current versus voltage, and then of course this to tell to see that it is rectifying. So this is the IV curve. This was for a lower current, and as you can see, the diode correctly works where it turns on, and it follows a law called Child's law, which is a 3/2 power law, which basically says that the current will increase 3/2 power to the voltage. And the reason it levels out right here is that the filament can only produce a limited number of electrons at a particular temperature. So what you're seeing right here is that as the voltage is increasing, eventually it'll capture all the electrons, and then it plateaus out, so you can't pull any more current through the diode. So that was as expected, so this came out well. And then this is the other one. This is when you have the filament on full, and this one you can get a lot more current out. You can get into the at about 50, 60 volts, about 0.5 milliamps through the circuit.